So this is like a homework problem, section 2.7, number 16. And I just thought I'd do a quick video on it because it demonstrates really well what we've been talking about in this section and pretty much the whole chapter. So it says solve the inequality, and so first of all focus on the fact that it's an inequality and don't lose track of that. So don't start writing the inequality symbol in as an equals, and remember the differences between an inequality and an equality. There's really only one change to the multiplication property that we have to apply, and I'm going to bring it up. Hopefully it'll be demonstrated. Here's what we do. We first clean up the left side. So I'm multiplying 2 times the entire quantity x plus 4, so that's going to be now 2x's and 8, just double everything, minus 8. And that's going to work out nice because the 8 minus 8 part is just going to make 0, so I've got 2x plus nothing. So left side's done, and I'm going to bring the inequality symbol down because I have not made any changes that would turn this symbol around. The only thing that's going to multiply, or that's going to make a change to the inequality symbol is if I multiply or divide by a negative. So then I'll take care of this. Multiply and clean up. We've got the opposite of x minus 4, and we're quintupling it, or we're multiplying it by 5. So negative 5x. And the opposite of a negative is positive, and 5 times as many as 4 is 20, plus we still have the 15. A common mistake that may be made here is that people distribute all the way through as if that negative 8 should be part of the group, or all the way through as if that 15 should be part of the group. But pay close attention that these are closed off with parentheses. So you shouldn't distribute all the way through, just the first two terms there. Now, because we can combine the 20 and the 15, I'm going to get negative 5x plus 35 on the right side of the inequality. Okay, this one is not going to require us to worry about that multiplying or dividing by a negative because I'm going to choose to add a 5x to both sides. And then I'll get 0x terms on the right side with 7x terms on the left. So 7x on the left, 7 times x is greater than 35, and there are many numbers that will make that true. Let's get at least down to the boundary or the end point of the list of numbers. So divide by 7 on both sides. Now I didn't divide by a negative number, so I don't have to switch the symbol around, which I'm going to write down first. This will still say greater than, but now I've got a single x greater than 5. That's the bottom of the list of numbers, and I can't actually include that, so I should reword that. It's not even on the list of numbers. It's at the bottom, right underneath our list, something like that. And if I wanted to write this with our set builder notation as we've been doing, I can say the set of all numbers such that, and then there's the property that the numbers are greater than 5, and that's my set. So let's demonstrate with a number line. And we will start at 0 just for the perspective. 1, 2, 3, 4, 5. You don't have to start at 0. I just keep wanting to give you a little bit more of the number line to look at. And then you've got bigger going this way, 7, 8, 9, 10, and smaller going this way, -6, -7, -8, -9, -10. Remember that we said if the number is, if the inequality is written with the letter on the left, which it is in this case, see how the letter is on the left, then we can kind of cheat here and just follow the inequality symbol as if it was an arrow pointing in the direction to shade. So we're going to be shading this way from our endpoint. We're going to shade to the right. Now what do we do actually at our endpoint, at the location of our endpoint? Well, this is a strict inequality, which means we can't actually include -5 in our list of numbers. So we'll want to have an open circle there. So if I was to use shading, I would do it like this. I'd say not actually including 5, but everything bigger than, and that means 5.0001, 5.00001, and definitely 6 and so on. Don't just think of integers though, because it could be 5.0000001. That would also be a number that would be greater than 5. All right, now we want to draw the interval. So again, let me get the names down for you. This is called the inequality notation, what I have here in black, or what I have here dark. And this is called the graph. And I've shaded to the right, and I've kind of used my little arrow since my letter was written on the left to remind me I'm going to go bigger. I'm going to shade to the right. And now I wanted the last one, which is the interval notation. The interval is going to start from, we read it from left to right just like we read the graph. So we're going to start from our endpoint 5, and we're going to go as big as we want. Those are all numbers greater than 5 when we think about going this way. Keep in mind, infinity is not an actual number, so we say we can't actually include that endpoint, or that side of the interval. We're just going to go up to it. And then since 5 is not included, because of the strict inequality used, we're going to use an open parenthesis there too. This is saying all the numbers that go from 5, not including 5, and bigger. And that's the answer. So you can stop the video here. That's the best way to capture everything that happened. It captures all of the numbers that are in the set, and it mimics the number line. And you can stop here, or if I was to have demonstrated this problem, and you'll probably think, why would you ever do that? And forcing myself, just absolutely requiring myself to put the negative, to put the letters on the right side. Suppose someone said, I always like to have my letters on the right. If I wanted the letter terms over here, and then the number terms over here, then the cleanup work would be the same. It would be double x, double 4, subtract 8, so it's just 2x over there. And then this would be the same, negative 5x plus 20. Be careful with that plus, because you did the opposite of 4 and then multiplied by 5. And then I would have done this. Again, it's going to seem awkward and weird because I'm forcing the letters to be on the left because I want to see what would happen. That would mean that I don't want letter terms on the left. So, I'm sorry, I'm forcing them to be on the right, which means I don't want them on the left. So I'm going to subtract the same amount of x's from each side, this side over here and this side over here. And then that also means that what I don't want on this side are number terms. So I'm going to subtract 35 from both sides. So I'll get 0 letters over here, and I'll get some letters there. I'll get 0 number terms over there. So now I have negative 35 on the left is greater than negative 7. So keep in mind, if I wanted to restrict myself to having letters on the right side, then I can make a move like this. It seems very unnatural, and I really am forcing it. But it gives me the chance to show that you could solve in either, with letters on the left or letters on the right in either direction, because eventually you're going to try to isolate the letter, and you're going to do something like, in this case, divide by negative 7, divide by the coefficient to get it by itself. You're going to get a 1x, but because you divided by a negative, you need to remember to switch the inequality, because we basically left our usual world, or our normal world, and we've gone into the opposite world. And so everything's going to turn around. make that smaller. And that's what happens when we turn it around. And then negative 35 divided by negative 7 is going to be positive 5. So it really is the same statement, and I won't go through with the rest of the work. It says 5 is less than a number. We had previously written it as a number greater than 5. But this can be rewritten to say, I'm thinking of the numbers that are bigger than 5. And you can see how those statements are equivalent. And if you wanted to squeeze in some set builder, you could say the set of all numbers such that 5 is less than the number. Well, that's the same thing as the set that we have over here. It's just worded the other way.